Assalamu alaikum. I'm Dr. Wael Muhammad, PhD in Applied Mathematics from Egypt for Edexcel AS Level Pure Math 1. Chapter 6 is Trigonometric ratios, and I will divide this chapter into two parts. The first part will talk about sine and cosine laws. Of course, we know that any triangle has 6 elements, which are 3 sides and 3 angles. But look at this triangle, please. Each angle with its opposite sides will form a very interesting couple or pair. And look at the symbols here. I named the angle A with uppercase and A small here with lowercase. The opposite side. Also look at B here. B as an angle with uppercase, and its opposite side will be with lowercase, and the same for C capital and C small here. Of course, we know that as any angle in any triangle be larger and larger, its opposite side will be larger and larger in length. And if you look at this triangle, you will see that the longest side will be opposite to the largest angle, and the smallest side will be opposite to the smallest angle. Moreover, we have a very interesting ratio, which is if we divide each side length over the sine of its opposite angle, we will get the same ratio in something called sine law. It's a very interesting law. And by equating any two ratios of them, we can form a proportion like this. Okay, A over sine A is equal to B over sine B is equal to C over sine C capital. And of course, we can flip each ratio upside down to form what's called the angle version. The first one is called side version, and the second one is called angle version. But the most important question now is at which conditions I can use this law. To use this law, from our background for algebra, you must have complete known ratio, complete known pair. You must know a side length and the opposite angle and any extra information. Okay, you must know two opposite data, side and its opposite angle, and then in extra information to use the sine law. I have a question now. If I know the angle A and its two legs, B small and C small, can I apply sine law? Of course not, because I don't have a complete pair. But we can use the cosine law now. If I know the angle A and its two legs, I can find the length of the opposite side of A. I can apply this rule. A squared here is equal to B squared plus C squared, which is very similar to Pythagoras theorem at the beginning here, and then minus 2 BC cosine A. And you must know that this is a general case. If A is right angle, cosine A will be 0 and all this quantity will be 0, and the remaining part will be exactly Pythagoras theorem. Also, if we want to know the rule such that B is subject, we can say B squared here is equal to A squared plus C squared, the sum of squares of two other sides, and then minus 2AC cosine B. Again, if you want to get C, we must know its opposite angle and its two legs. And the rule will say that C squared is equal to B squared plus A squared minus 2AB cosine C. These are the side version, and we can get the angle version. If we know the three side lengths, we can move negative 2BC cosine A to the left hand side with positive sign, and move A squared here with negative sign, and write cosine A equals B squared plus C squared minus A squared divided by 2BC. Okay, a very important note here. Look at the first rule. We start with A small and end with cosine A capital. And here we start with cosine A and end with minus A squared. So they are very interesting rules. Let's go to the example. We can divide our problems into three cases. The first case, which is two angles and one side. Okay, we can't solve any triangle except if we have at least one side. So in the case of just one side and the other two angles are known, like this example here, We have this angle is 48, this is 84, and this is 14.6. I want to solve this triangle, which means I want to get x, y, and m. First of all, I can get x because the sum of the angles of any triangle is add up to 180. So x equals 180 minus 48 plus 84. The result is 48. We are lucky in this example because 48 here and 48 here, it's an isosceles triangle. So m also should be 14.6. What about y? To get y, we can apply simply the sine rule, which states that y small divided by sine 84 is equal to 14.6 divided by sine 48. And then we can get the value of y. The second case, let's increase the number of sides now. If we have two sides and just one angle, in this case, it's very important to ask ourselves what's the location of this angle with respect to the known sides, which means if the case is angle side angle, or the case is SAS, which means that the angle is in between the known sides. In the first case here, let's take this example. Look at please this interesting angle 130 and its opposite side, which is known. And remember that I told you before, if we have a known pair, we can apply directly sine rule. So I can get sine rule now. How I can get the angle which is opposite to the known side 6 here. So I can write sine x divided by 6 equals sine 130 divided by 12.8. In this case, I can get sine x at first and then make shift sign to get the value of x. Don't forget that sine theta is the same as sine 180 minus theta. But in this case, we are sure that x is an acute angle because in any triangle, we don't have more than one obtuse angle, of course. And then we can get y, 180 minus the sum of x and 130. And then we can get z by completing the third ratio here. We can say this equals sine y divided by z, and then we can get the value of z. Okay, for the SAS case, which is very interesting. In this case, we don't have any known pair of an angle and its opposite side, and this forces us to apply the cosine law, which states that x squared is equal to 9.6 squared plus 4.8 squared minus 2 times 9.6 times 4.8 times cosine 45. By taking the square root, we can get the value of x to be approximately equal to 7.07 centimeters. After knowing the value of x, we can get an angle like y or z by applying sine law. I prefer to get the largest angle, which is opposite to the largest side, which is y. I can say sine y over 9.6 is equal to sine 45 divided by x, and in this case we can say y is equal to 73.3.7 or y approximately equal 106.3. Which angle should we select? Of course, from the figure, y is obtuse angle, and if to remove any doubt, we can square 9.6 and square 4.8 and square x and compare. If the largest side square is more than sum of other two squares, it will be obtuse, of course. So it will be 106.3. Then we can get z by 180 minus sum of the other two angles. Let's increase our sides now. If we have three sides like this, of course we will apply cosine law, but in the angle version. As I told you, I prefer to get the angle which is opposite to the largest side, which is x here. Cosine x is equal to sum of squares of its two legs, 3 square plus 5 square minus 6 square divided by 2 times 3 times 5. By making shift cosine, we can get the angle to be 93.8, which means that it's obtuse angle. The other two angles should be acute angle. We can get y or z by applying sine law. We can say sine y over 5 is equal to sine x divided by 6. After that, we can say sine y equals 5 sine x divided by 6. By making shift sign, we can get y, and then we can get z by 180 minus some of the other two angles. Okay, let's start with the problems. In triangle ABD, to get cosine A, we'll apply cosine law with angle version. We can say that cosine A is equal to the sum of squares of its two legs, 4.2 squares plus 2.1 squared minus the opposite side squared 5.9 squared divided by 2 times 4.2 times 2.1. A is approximately equal to 136.3 for one decimal place, okay? For the second triangle, we can apply the same rule with the angle C. So cosine C will be equal 7.5 squared plus 3.5 squared minus 5.9 squared divided by 2 times 7.5 times 3.5 and by using our calculator. And then C will be 50.1 for one decimal place also. B, find the total area of the floor bed. We can get the sum of the two areas right directly, right? We can say that the total area should be the area of the first triangle half times 4.2 times 2.1 multiplied by sine angle A and plus half the product of 7.5 times 3.5 times sine the angle C, and the final answer should be 13.1 meters squared. C, find the length of the diagonal AC. To get the length of AC, we can put it in either one of these triangles, ABC or ADC. Let's put it in triangle ABC. So I will find this angle at first, and from the triangle ABD, and I will get an Y here from triangle BCD, and then by adding X and Y, we can get the total angle of B, and then in triangle ABC, I will have AB and BC and the angle B, which is SAS case, to get the length of AC. It's a very interesting question. Let's start to solve it. For triangle ABD, you can say that sine x divided by 2.1 is equal to sine A divided by 5.9. And in triangle BCD, we can say that sine y over 3.5 is equal to sine C divided by 5.9. By this way, we can get the value of angle x and the measure of angle y also. Then in triangle ABC, we can say that AC squared is equal to 4.2 squared plus 7.5 squared minus 2 times 4.2 times 7.5 times angle B, which is x plus y. And then in triangle ABC, we can apply cosine law to get the length of AC. AC squared is equal to 4.2 squared plus 7.5 squared minus 2 times 4.2 times 7.5 times cosine B, which is x plus y together. I prefer to restore our result in x. I prefer to store our result in for x and y and then recall them again in finding AC. And finally, AC should be 5.15 meter to three significant figures. Question 15, ABCD is a square, angle CED is obtuse angle. Okay, angle CED is obtuse. This information can help us if we will apply sine law here, and then we will choose the obtuse angle. Okay. Find the area of the shaded triangle. What a nice question. Our strategy here that I will find the area of the square minus the three unshaded triangles to get the area of shaded triangle. So I will start with the triangle which has more data, which is triangle CED. This angle is 40 and this angle is 50, and we have this angle and the corresponding side length, which allow us to use sine law, and this is 10 centimeter, right? So in triangle ECD, we can apply sine law as following. Let this angle be x, so sine x divided by 10 is equal to sine 50 divided by 8. By this way, we can get the value of x. It will be 106.753 and so on. And don't forget that the question said that this angle is obtuse angle, okay? Also, we can find in this triangle the measure of angle y, because y now is equal to 180 minus 50 plus x. Also, we can get the length of CE, right? We can complete the sine law here and write sine y divided by CE to get the length of CE to be 10 sine y divided by sine x. So that CE will be 8 sine y divided by sine 50, which is 4.12187, so on. Now for the first triangle here, I can give the area, which will be half times 10 times 8 times sine y. And for the second triangle, I can give the area as it will be half times 10 times 8 also times sine 90 minus y. Okay, and for the third triangle, I can get its area by half times 10, which is CB times CE times sine 40. Okay, and subtract all of them from the square area. Okay, this is the area of the square minus this is the area of the first triangle plus area of the second one, area of the third one, and the final answer should be approximately equal 34.2 centimeters squared. Okay, we have another idea. We can, from the area of just the first triangle DEC, we can, using the formula which states that half base times height. Okay, and by this way we can get the height, and then the height of the shaded triangle will be 10 minus the height of the triangle like EE dash. Okay, EE dash here is another way. Okay, and then we can get the area of the shaded triangle by half base times height. Okay, what a nice question. From chapter review, question 7, the 3 points A, B, and C with coordinates A01, B34, and C13 respectively are joined to form a triangle. A show that cosine angle ACB is negative 4 over 5. Since cosine is negative, which means that C is obtuse angle, okay? According to the distance rule, we can get AC, which is square root of 1 minus 0, 1, square root 1, and then 3 minus 1, 2, square root 4, to be square root of 5. BC is equal to square root of 3 minus 1, 2 squared will be 4, and then 4 minus 3, 1 squared will be 1, square root of 5, and finally AB is equal to square root of 3 minus 0, 3 squared 9 plus 4 minus 1, 3 squared 9 also, which will be 3 root 2. Then cosine angle C is equal to sum of squares of its two legs, 5 plus 5, 5 plus 5 minus square root 18, which is 18, and then divided by 2 times root 5 times root 5, which means that we have 10 minus 18, negative 8, divided by 2 times 5, which is 10, which can be simplified to negative 4 over 5, exactly the required. B, calculate the area of triangle ABC. To get the area, of course, we know that half product of two adjacent sides, like root 5 times root 5 times sine the angle C. To get sine angle C, we can make shift cosine and then sine the angle. To get sine C, we can draw this simple triangle. We know that cosine means adjacent over hypotenuse, so this is the hypotenuse, this is the adjacent, and so that we can get this side easily by squaring 5 minus square 4, which will give us, and then take the square root to be 3. We have a famous triangle 3, 4, 5, and then sine C should be 3 over 5, and since C is obtuse angle, its sign is positive, okay? So the area will be root 5 times root 5, 5, it will be half times 5 times 3 over 5, which finally be 1.5 squared unit, okay? The longest side of a triangle has length 2x minus 1 centimeter. The other sides have lengths x minus 1 and x plus 1. Given that the largest angle is 120 degrees, work out the value of x. Very nice question. From cosine law, we can write 2x minus 1 all equals x plus 1 all squared plus x minus 1 all squared minus 2 x plus 1 times x minus 1 times cosine 120. Expanding the left hand side, we have 4x squared minus 4x, and then plus 1 is equal to x squared plus 2x plus 1, plus also we have here x squared minus 2x plus 1, and here we can say that cosine 120 is negative 1 over 2, Negative times negative will be positive, and the half will cancel too. Okay, so we have here x plus 1 times x minus 1, which is positive, of course, now. X squared minus 1. Okay, we have here x squared plus x squared plus x squared, 3x squared to the other side with negative sign, so that we have 4x squared minus 3x squared, just 1x squared. And then we have here 2x can be cancelled with negative 2x, so we have minus 4x here. And finally 1 plus 1 minus 1, we just have 1 minus, okay, equals 0. So taking x as a common factor, we have here x minus 4 is equal to 0, which means that x, of course, x can't be 4 because we have x minus 1. We don't have negative length. X equal 4 centimeter. Okay. B, find the area. To get the area, we can apply the rule of half, the product of this side with this side. 4 plus 1, 5, and 4 minus 1 here is 3. And then sine 120. Sine 120 is the same as sine 60, which is root 3 over 2. So the final answer should be 15 root 3 over 4. Question 9. A parkkeeper walks 1.2 km due north from his hut at point A to point B. Okay. He then walks 1.4 km on a bearing of 110 degrees. Okay. To reach point C. Okay. Find how far is from his hut when at point C. The required is to get the distance AC. And of course we have side angle because that angle is 70 side. So directly to answer part A, we can say that AC squared is equal to 1.2 squared plus 1.4 squared minus 2 times 1.2 times 1.4 times cosine 70. Okay. Then AC approximately equal 1.5 km to 3 significant figures as the question asks. B, work out the bearing of the hut from point C. From point C, this is the vertex and this is the hut. Okay, the required is to, okay, draw the north at first. This angle is required. Okay, give your answer to the nearest degree. Okay. Okay, since this angle is 70, this is also 70, alternate angles, and from this triangle we can get the value of x. Okay, we can say sine x divided by the opposite side length 1.2 is equal to sine 70, which is the given angle here, divided by AC, which is 1.5. To get sine x should be 1.2 sine 70 divided by 1.5, and in this case we can find the value of x. And then the bearing of A from C is 360 minus 70 plus x, which would be 214 to the nearest degree. Okay, C, work out the area of enclosed walk. Piece of cake, we can say half times 1.2 times 1.4 times sine 70. It will be approximately equal 0.789 kilometers squared. A windmill has 4 identical triangular sails made from wood. If each triangle has sides of length 12, 15, and 20 meters, work out the total area of the wood needed. Of course, it's a very easy question. The square of 12 is 144, the square is 15 is 225, the square of 20 is 400, so it will be an obtuse triangle, right? To get the area of one of these triangles, we want to get the value of x. So by applying cosine law, we can say that cosine x is equal to 12 squared, which is 144, plus 15 squared, 225, minus 20 squared, which is 400, divided by 2 times 12 times 15. And by making shift to cosine, we can get the value of x to be 94.9399 and so on. Then the area of the 4 triangles will be 4 times the area of this triangle, which is half times 12 times 15 times sine x, and the final answer should be 358.66 meters squared. 2 points A and B are on level ground. A tower at point C has an angle of elevation from A of 15 degrees and an angle of elevation from B of 32 degrees. A and B are both on the same side of C, and A, B, and C lie in the same straight line. This distance AB 75 meters. Find the height of the tower. Let's sketch the problem. This is our problem. For this angle 32, it's an exterior angle of the left triangle here. So directly we can find the measure of this angle to be 32 minus 15, which is 17 degrees. And now in this triangle we have a complete pair, which means side and its opposite angle. So we can apply sine rule in this triangle. Okay? In triangle ABD we have the following. We have 75 divided by sine 17 is equal to BD divided by sine 15, from which we can get BD. Okay, then we will pass our information to the right triangle now. For triangle BCD, in triangle BCD we can set that sine 32 is equal to H divided by BD. So here H can be BD times sine 32, which means that BD is 75 sine 15 divided by sine 17 and then times sine 32 to be 35.2 meters. We have another method now. If we call BC to be X, from the right triangle we can say that tan 32 is equal to opposite, which is H, divided by adjacent, which is X, right? And also for the big triangle ACD, we can say that tan 15 is equal to H divided by 75 plus X. So from the first ratio here, we can say that H is equal to X tan 32. From the second one, we can say that H equals 75 plus X all multiplied by tan 15. And then we can solve for X and then solve for H in the first one, which will give the same answer, of course. Thank you for watching, and see you in the next video, the second part of this chapter about how to sketch sine, cosine, and tan graphs. Thank you very much. Assalamu alaikum.